and all credit goes to them. So far, so forth. We will continue. So I was doing this and I realized I wasn't recording correctly. So I just put these names here just to notify myself which professor's notes I need to look at. So let me get back to you a little bit quickly. To be fair, a lot of people have done all this before. I'm just rehashing people. And according to Dr. Sanchez, all of this has been mostly done 50 years ago. So we're old, so it's kind of old. Um, so yeah. So anyways, let me just now come here and talk a little bit about this. So it makes sense actually now this is a class now rather than a research topic. Anyways, this over here is clearly our classical. Um, this is the this is the definition that we have used forever and ever and ever when we think of airplanes and lift. This is the one we learned in 101A and 101B. Nothing too crazy. It's just 104, 101A, 101B, and everything in between. We kept on using this format here. And after that, we go to a more complicated one like shock waves over here, which has some kind of we don't need to talk more about that. But there's a bow shock and a trailing edge shock, and there is some oblique shock and so on and so forth. This is, I think, oblique. Probably more heat over here, but I don't really need to talk about Q yet, and I hope I don't have to yet. Because that would be hard for me right now because I need to look at my Dolan notes and I don't remember too much about thermo. There's CP minus CV over here, and this is our kingpin as always. And then there's these definitions I never remember because I know specifically, yeah, I never used them. But hey, if you find a use for it, then thank you for giving me hope on this thing because I have never found a use for it yet in my life. So yes, over here is the use of those. Okay. Okay, we're getting there, right? Yeah. Yeah, I should do it. Eh, Okay, let's do it. Alpha equals CP divided by CV. CP minus CV equal R. So 1 divided by CV divided by CP equal R. And we know this is 1 minus 1 over alpha equal R. And a little bit of rearranging. Wait, did I do this correctly? Yeah. Okay, we did. Yeah. No, no, I did not. I forgot to divide by CP over here. And then we have a little bit of rearranging shows you that alpha minus 1 over alpha. That means there's an alpha minus, there's this idea over here that shows you that it is, uh, I forgot. There's a CP over here and it's equal to R uh, divided by 1 minus 1 over alpha parentheses. And this, if you simplify it enough, gets you the other forms. You can do it yourself. It's not really I should do it. I keep on saying you should do it yourself, but then again, I should show everything off possible. It's because especially if there's infinite time. Right now, we're not dealing with like my time can be used whatever anyone wants to abuse it. It's fine as long as as long as just I don't know. I'm saying shit up. I don't know what I'm saying anymore. Um, yeah, this equals alpha r divided by 1 minus alpha, I think. Because 1 minus 1 divided by alpha equals alpha 1 minus alpha, which gives you equal to alpha minus 1 over alpha. And you can see that I did it wrong. Alpha, and this should be 1. Yes, that is correct. Yep. And then the other way to do it is CP minus CV equal R, and you divide the opposite way, equal RCV, and we know this is alpha minus 1 equal R divided by CV, and we understand that CV equal R over alpha minus 1. And with that said, you have derived it from that. I do not want to do that again. So why actually that was not bad. I was just being crybaby. All right, I'm a crybaby now. I guess I am. Let's see. There's the PV equal RT that I have talked multiple times. No, I talked about density. Okay, I need to talk about different forms of P ideal gas law, which sure, fair enough. I should probably talk about P. Oh, P. Oh my God, my handwriting is shit. As always, it's garbage. PV equal RT or GT. That's how it's written in Dr. Sanchez's notes. So we're gonna use it. Even if other textbooks are doing that, we will follow Dr. Sanchez's notation mostly. Um, Now, this BV I don't like. I never liked how that Pacific volume is used because there's density over here and this RG over T. The Pacific volume is equal 1 over density. But notice here, I don't like Pacific volume because that looks like a velocity. And I don't want to get confused by it. So I always like to use the density definition. Screw the specific volume, like get rid of it. Like I don't use it. I don't want to use it, but I will have to use it. This is how I remember it. Yes. It always confuses me. So yeah, I don't like to use it. Um, Anyways, other definitions I should remember. I believe it's like I believe there's a dE equals CV dt. Oh my God, I need new batteries for this. I'm able to use my tablet because my I keep on forgetting to buy batteries for my tablet. Anyways, it's dH equals CP dt, I believe. And then that's all I should. My pen is not working, so I'm gonna have to be careful here. Um, I need to get new batteries. Pronto. Okay, there's also this of the Gibbs equation. I mean, I think we did most of these Gibbs equations. The only thing I don't think we did was doing this integral. So I guess we can do that. Oh, I almost got confused here because the way they write it, again, they use specific volume, which is going to get confusing when we do thermodynamics. So I would recommend you rewrite that and write it as E plus this. This to me is the superior way to write it. This is it actually confused my brain a little bit because I knew this is not true, and I thought why is there velocity in here or something, which well, I'm stupid for believing, but it should be 1 over d. I recommend this method because this method is superior and better in every way, and no one can tell me otherwise. Yeah. So, yeah. Anyways, we already did this part last time, I think. And if I didn't do it, then tell me later in the. So you know what? We'll do it. We'll just do it. Uh, okay. So first thing we have to do is H equal E plus P over density, right? And it's dH equal dE plus dP over density. And this is a product rule. So I'm just thinking the pen right now because it's not working. dH equal dE plus, this is why I write paper notes, man. Over here we have this. I believe that is right. Yes, I believe that's right. And from this, we can substitute in because we can say dE, let me just go smaller because it's not going to equal minus dH minus dP, density minus d1 over density. And over here, we can then plug into over here, which is T ds equal no minus this plus dH minus dP over density minus P and D1 over density. And you can see where we're going with this because there's a plus, there's also a plus P D1 over density. So these two go away, and I know that D doesn't like D, but that's because of my pen. Anyways, we can move on to say that this is true. And if you're asking why that looks like shit, it's because of my pen again. This pen needs new batteries, and I'm too lazy to buy one in the supermarket. Yeah. Over here is next. We go to, oh, please rejoin. I wasn't joining, so that's why my yeah, CPDT. Yes. And with that said, we need to look at uh, Gibbs equation again, and we need to plug back in and manipulate. So we start with T ds equal dH minus dP over density, right? So we plug this over here. We say T ds equals Cp dt. And we could have done Cv also. No, we can't. That's for the E version. Um, yeah, so you could have, I didn't. So we have this version over here, right? All right. So now we do ds equal Cp dt over T minus dP over density T. Now this density T is a problematic situation because temperature if is integrable with so T is a function of what I'm trying to say, I don't know. I'm trying to say that you can get P equal uh, density RT, so we can get density and T over here to get pressure. But I'm not putting that well in. So just ignore the bad stuff I'm saying and just accept that I'm doing okay job. And no, even probably bad job on some of the explanation uh because I don't know what I'm saying anymore. Um, dp over p, and there we have it. Now with this, what can we do? What can we do with this information? So I believe you can integrate this, and then you can use this to find the ratio of Pu2 divided by P1 equal T, the temperature, T, something like this. Yeah, I think. Either way, that is the reason why I needed this, because otherwise we couldn't get to the portion we want. What I'm trying to say is we're trying to get into one minus yeah. We're trying to get to this equation over here. But how do you get all of these terms over here? Well, that is due to that form we're gonna put up. Um, yes, I'm pretty sure this is how you do it. Let me look at the textbook real quick because textbook is king. Yes, that's how you do it. Although I must say the textbook uh does it in what's the right word? In the hard way, the long about way, the hard way, which will be difficult for you to look at, but it will be possible. I'm not saying it's impossible, but it'll be hard to look at. So we're going to rejoin. No, no, we're not going to stop here, and then we're just going to move back up over here, and then we're going to follow you. Follow you. Stop following. Following. Go there. Okay, stop following, and then follow my view. Okay, we're good. Okay. Okay, here we go. When S1 equals S2, oh, I forgot to integrate. That's why it wasn't getting the right. So when you integrate this, it's S1 minus S2, right? And then this must be equal to each other. So this is just 0. Um, so yeah, that was kind of obvious when we talked about earlier. What we're saying is we're claiming the portion over here where we did all of this to say S equal constant or something. Um, and moving up over here. And then we have basically 0 equals CP ln T2 over T1 minus R ln P2 over P1. And this shows you the proper steps over here. And you kind of see where this came from. Now that shows you P2 over P1 equals, now over here, if you look at back, it'll be alpha minus 1 over alpha. And look over here, that is the same exact stuff that he was mentioning over here about this. Alpha equals 1. And now we're getting there. We're getting to the situation where we got everything. We have it all. The only one that we haven't have is this portion now. This portion with the Mach number, which honestly